Here we're going to look at 1.2.3, understand stretches and compressions, part A. So we're told to graph f of x equals the absolute value of x, which I've got the chart here, with a domain of -4, 4, which is why I picked -4 to -2, 0, 2, and 4. And then g of x, which is 2 times the f of x, and how are the domains and ranges related. So for here, the -4, -2, 0, 2, 4, I plugged each of those x values into the absolute value function and then got my results, and then I've plotted them over here. Now, I want to make sure that when I draw these lines, they have a terminating point because we have a set domain. We're not going to go past -4 or +4, so we're going to stay there. Now, second part of this is they're telling us to do 2 times f of x. So what I want to do is I want to keep my x values. I'm going to keep -4, -2, 0, 2, and 4. And I'm going to look to come up with my new y values. So if I plug in each of these points, -4 in as x, I get the absolute value of -4, which is 4, times 2 is 8. And then I'm going to take each of these 5 here, plug them into this, and get my y values. So 4, 0, 4, and 8. So I'm now going to plot these points. I get -4, 8, -2, 4, 0, 0, 2, 4, and 4, 8. Now I'm going to do the same thing. I'm going to connect these. It's not the straightest of lines. And one more time, I'm not going to extend past that -4, 4 because we're still looking at that as my domain. All right, so what happened to my graph here? Well, if I look at this, it looks like a lot of my points shifted up. All right, but I want to be careful with phrasing that it shifted, because if I look down here, actually let's fix that line. It wasn't terribly accurate. All right, that's better. If I look down here, 0, 0 stayed the same. All right, that point didn't shift. Okay, so not all of my points are being shifted. What's actually happening is my graph is being what we call a stretch. All right, so this point is being kind of pulled up here. All right, the whole function is not shifting up. All of these points are just being stretched up here. And as I get closer to that vertex, notice that it looks like it's getting pulled less and less. Although it will be at the same rate, just not going to be the same amount. So these points are being pulled up, and we're looking at what's called a stretch. I'll get into that more detail in a minute. So how are the domains and ranges related? So my domain for f of x, they told me was -4, 4. Now, what about g of x? Well, my x values still go from -4 to 4. So my domain didn't change. My domain has remained the same. So let's take a look at the range. My range for f of x minimum, the lowest that my y values were was 0. And the largest that my y values were, again in f of x, was 4. It never went above 4. But in g of x, I still have that same minimum of 0, but my graph has been pulled up, it's been stretched to 8. So what's happening here is my range has been expanded. So since the range has been expanded, and again, we're trying to stretch this graph, it looks, really it looks like it's gotten taller. All right, that black one was a little more flattened, and this red graph we're stretching up. So since my range has been extended, that tells me that there's a vertical stretch. Now, here's how we actually know this. Let's say we have our function, and then we're going to take that function and we're going to multiply it by a number. Let's call this number a. So we're going to do a times f of x, which in this problem, this specific problem, that 2 would be our a value. That a is going to tell me whether there is a stretch or what is called a compression. A compression is going to make my range smaller. All right. If I was to look at this, a stretch would have meant my graph would have kind of gotten flattened out, something like that. But we're not looking at that, so let's get rid of that so we don't confuse ourselves. But compressions are when they're kind of flattened. Now, to determine whether there is a vertical stretch or a compression, you're going to have a stretch when A is greater than 1. And you're going to have a compression when your A value is between 0 and 1. Now, because this is math and this gets even more confusing, let's say that there was a negative in front of here, in front of that A. We're going to disregard that. Okay, that negative, as we mentioned in the last series of videos, those negatives are going to affect reflections. So when we're looking at stretches and compressions, we're only looking at that A value in front. We don't care about that negative. Sometimes you'll see people say the stretch is the absolute value of A. That way, in case you look at that negative, you eliminate it. So without too much confusion, and I know this kind of seems like a lot, when you're looking at stretches and compressions, okay, vertical stretch and vertical compression, the number outside of that function, that 2 in this case, that A value, it'll be a stretch when that A value is greater than 1, and it's a compression when A is between 0 and 1. Something like 1/2 or 1/3 or 3/8. So this information is your key information right here. Make sure you remember this, note that down. This specific problem had a vertical stretch.